Hi, this is Sarah Parker, and I will be doing my code explanation for CPSC5010 Assignments 4, which is 4 separate programs. Our first assignment is 4.1, and this program asks a user to input an integer, and then the program will use a function to reverse the numbers in those integers. So if somebody inputs 123, then the output is 321. It takes the integers and prints them out backwards. So for this, we created a function called void reverse. So we're not actually returning any numbers, but it is going to take a number in, and then we'll have our integer is our digit. This function is a do while, so it's always going to do it first, and then it's going to check the while condition. So the first thing it does is it's going to extract the last digit. So this is our digit is our number, and it's going to be modulo 10. We're going to print that digit out, and then our new number is going to be divided by 10. So we're extracting the digit, printing it, removing the digit. And we're going to keep doing that while our number is greater than 0. So that's how we will print out our numbers backwards. We'll always take the last digit, print it, remove it, take the last digit, print it, remove it. So to test this, in our main method, we have our integer, our variable integer number, and we're going to print to the terminal to enter an integer, and then we're going to save whatever our user inputs as cin into the number, and then we're going to call that function reverse, this one up here, with the number that the user has entered. So if we go to our terminal down here, let's clear that out. We'll do that program in a little bit. Okay, for the first one. So this is our reverse integer program. So we're going to enter our integer. We'll make it a little long. We'll do 74329. And we should expect 92347. And we get 92347. So that is our first program. Our second program is twin primes. So this program is going to find twin primes. So primes that are two integers apart from each other, like 3 and 5, 5 and 7, etc., all the way up to 1,000. So to find this, we created two functions. So the first function is a Boolean function called isPrime, and this is going to check our numbers first to see if it's even a prime number. If it's not a prime number, we don't care about it. We just want to move on to the next one. So we're starting at 2 because we don't care about 0 and 1. They're not prime numbers. And then we're going to do I less than or equal to our number. This is our number that we're inputting. And then I plus plus. If the number is divided modulo I, then is equal to 0, we'll return that as false. So that tells us that we do not have a prime number, but if it isn't, then we'll return it as true. We're going to use this function inside our next function, which is find twin primes. So right here, we're going to start at 2 again, and this time we're going to go up to our max range, which we have set as a variable here, which is 1,000, and then we're going to increment that. So we're going to go through this loop every single time until we hit 1,000. The first thing we want to know is I a prime? So that's how we're using our function inside another function. And we also want to know if the number 2 above it is a prime. So that's how we determine whether they're twin primes or not. We want to know, is I a prime, and is the number 2 above it a prime? If it is, then we're going to output those two numbers. And if it's not, then we're moving on to our next I number. To test this, we're just doing it in our main function, which is find twin primes. So we're just calling our function. It does not call any parameters. The only thing that we're doing is calling another function inside, which does call a parameter. And then we're returning 0. So if we run this program, we should output all of our twin primes. And you can see we have all of our twin primes, 5 and 7, 3 and 5, all the way up to 881 and 883. So that is assignment 4.2. Assignment 4.3, we are starting to work with arrays a little bit more. So this is called employee hours, and essentially we're creating a two-dimensional array that is our employees and the total hours each day that an employee has worked, and then we'll use some functions further on. So the first thing we want to do is we created our I set this for 5 employees, and then our days is constant, that's 7. So we don't want to be able to change our employees. We set it as a constant. We're not changing the days in the week, that's a constant. So in the display hours, our parameters that we're taking in is a 2D array, and we're going to call this hours, and it's taking in employees and days. It's calculating the total number of hours for each employee and saving it in an array. So for I equal to 0, I less than our employees, so we're only going to go through our rows, and then we're going to go through our columns. So we're going to take our total numbers at I plus equal our hours ij. So that's going to sum up the hours for each employee for the week, and that will come up with our total. So we'll have our employees, and then we'll have our total hours created. The next thing that I created was an array to store the original employee ID, because otherwise the numbers kind of got messed up when we ran it later. So I created a separate array just with the employee IDs, and we started the employee ID at 1 and we just went to 5. So we're looping through and going 1 through 5. The next thing that we're asked to do is to sort this information of employees and their total hours they worked in descending order. And we want to save their employee ID to the right employee. So we want the employees that have worked the most to be at the top with the correct employee number, and then descending down by hours, not by employee ID. So again, we're starting at 0 and we're going through our full array, employees minus 1. Because we're starting at 0. So that's why it's employees minus 1. And then in our inner loop, we're going to j equals I plus 1, and then less than employees, and then j plus plus. So if at the first index, our total hours at I is less than our total hours at j, that's why we're looking at I plus 1. We're looking at the first one, and we're looking at the second one. Then we want to do a swap. And the way that we do a swap is we create a temporary, basically, variable. It's just a local variable, and we're saving the variable at I to the temporary one. Then we're moving j into the index of I, and then at the j index, we're saving our temp. So we're moving j over to I, and then I back over to j. But in order to do that, we need our middle temporary variable. And if we're doing that with the hours, so if this condition is met and we're swapping the hours, then we also want to swap the employee IDs so that the right ID is saved in the right slot as well. So it's the same type of swap, it's just taking the employee IDs instead of the total hours. So that's how we are sorting our employees by their hours and saving their IDs. And then we're going to display the total hours in descending order. So we're just looping through our employees, and we're printing out the total hours that the employee ID at I, and then the total hours at I. So this is our 2D array that we created in our main method. So I just picked some random numbers for each of our employees. This is employee 1, 2, 3, 4, 5. These are the 7 days that they have worked. And then we're going to call our function display hours with our parameter being passed through as hours, which is this 2D array right here getting passed into this function, which is what this calls for. We need a 2D array in order for this function to run. So let's run the program. And we can see that employee 1 worked a total of 42 hours, employee 5 worked a total of 38 hours, employee 4 and 2 worked the same, and then employee 3 worked the least amount at 30 hours. So it did successfully sort it from highest to lowest, but it also saved the correct employee ID with that number as well. So that is the third program. The fourth program is a tick. Okay, this is an update to CPSC5010 assignment 4. As I was going back finishing the project, I realized that I did assignment 4.4 incorrectly on the tic-tac-toe game. So in the instructions, it called for a dynamic array to be used, and I was using a static 2D array. So a dynamic array allows for greater flexibility because you can change the size because you're allocating and deallocating memory according to what you need. So most of the logic for the game is the same, except you're going to see one big change. So instead of our 2D array here, we're using a pointer to board. And same thing with check when. This is a pointer for board, and we'll go check on board here in a second. But we're using pointers this time. And pointers allocate where in memory something is located. And when you use a pointer, you're also allocating memory on the heap instead of the stack. So for very large arrays, this can be much more efficient than clogging up your stack full of unnecessary variables. So here's the big change. Let me find it. Here we go. Okay, and our main method, we're allocating memory for the board. This is where we're creating our dynamic array instead of our just static 2D array. So this is the key line right here. Character, star, star, board equals new character, star, size. We're allocating memory. We're saying that we are creating a pointer, which is going to point to board. It's a character pointer, and we're going to fill it with our array of character pointers. So it's a pointer of pointers, and each pointer in our array is going to point to the specific character. So we're pointing to the board, and then from the board, we're pointing to each element, and each of those character elements is pointing to the actual element. So that's where we are different than what we had done before. And we're going to initialize this board. So this just allocates the memory for it. Now we're going to initialize it, and this is going to initialize it 1, 2, 3, 4, 5, 6, 7, 8, 9. We're starting at 1, going up to our size. And so that way we have our 1, 2, 3 all the way down. So other than that, the logic for it is still the exact same. The only thing that is good practice to do is to deallocate your memory when you're done with the game. So we can just free up all that space on the heap. And we do that by first deleting our pointers in our board pointer. So the little pointers inside the big pointer. So we're going to do a for loop, and we're going to go through all of those, and we're going to delete the board at I, and then we're going to delete the whole pointer board. So that will free up all the memory that we used. The game is going to work the exact same, and I won't run through the whole thing, but it's just a more efficient way to write this program by using a dynamic array. Let's try again. Oh, let's do it this way because I'm not in the right folder on here. So we'll build it and we'll compile it. It's being real slow. Okay, it is working. Let's give it a second. Not quite sure why it's taking so long. There we go. So our board still looks exactly the same, but instead of it being a static 2D array, we're now using a dynamic array. So that is the updated and the improved version of the tic-tac-toe code that I had previously explained. Thank you.